All right, so when we're maximising, we are trying to find the biggest numbers. So we're trying to assign whatever it is to the biggest numbers instead of the smaller ones. So everything we've done up to now has been about minimising. This time we're about maximising. So the way which we do this so that we can still use the Hungarian algorithm is we make all the big numbers smaller numbers and all the smaller numbers bigger numbers, but we have to do it in a systematic way. To do that, we find the biggest number in the matrix. So for example, in this example here, we find the biggest number, which is 33. And we go, okay, so we need to make the biggest number a 0 and all the smaller ones bigger numbers for later. So what we do is we go, let's look at 33 and let's subtract those numbers all from 33 to be able to change those numbers. So I end up writing like this: 33 take 29, 33 take 29, 33 take 31. Now you don't have to write all of the, I want you to write this in your notes, but it's the only time you're ever going to write it like this, okay? Because you'll just go straight to your next step. Right now, I'll just erase this so we can actually do it properly. And so if we take each number from the biggest number, we end up with, what's 33 take 29? 4, 4, 2, 7, 9, 5, 11, 0, and 11. Does everyone agree with those numbers? So you're going to always end up with at least 1 0 in your new cost matrix, because that biggest number is going to end up being 0. But you notice the smallest number in the table, which was 22, is now the biggest number. Okay, so what we've done is we've just switched it around so that we can use our minimising technique to find the answer. So all that this question is doing is we're just making all the big numbers small and all small numbers big. Okay, but all you guys need to remember is find the biggest number, take every number from it, change it. Okay, that's the only change. So then after this, we're going to use our Hungarian algorithm to be able to solve it. So what's the first step I do? I'm going to the rows. So I'm going to do my row matrix. So the smallest number in the first row is 2. So I end up with 2, 2, 0. Smallest number in the second row is 5. So I end up with 2, 4, 0. Smallest number in the third row is 0. So we end up with still with 11, 0, 11. And I think over the last few days, the biggest mistake people have made is when there's a 0 in a row or a column and they still try and subtract a different number. 0 counts as the smallest number, okay? Then I'm going to look at my columns. Now, often, especially with questions like this, the column one doesn't always have to change. If there's a 0 in every column, you don't have to redraw the column matrix because it's just going to be exactly the same. But for this one, there isn't a 0 in every column, so we do, because we need to take the 2 off these. So we end up with 0, 0, 9. But then the next 2 columns are exactly the same because you have zeros in them already. All right, so what do we need to do now? Put the lines through. So we use the doubles first. So I'm going to say this one and then this one and then this one. Do we have a solution? Yes. Now, what's the problem with this one? I know this one's definitely an answer. There's actually 2 answers, because I could use this 0 and therefore I have to use this one. And so that would be one set of solutions. Or I could use this 0 and therefore have to use this 0 as well as this one. So if you see, there won't ever be like 3 or 4 solutions, but there could be 2. And so you'd actually need to write your 2 solutions. So for this question, because you had the numbers, you need to now go back to the numbers which started, and you would say A has task 1, which is 29, B has task 3, which is 28, C has task 2, which is 33, which is 90, or the other way around. So you need to write both solutions as you go. Now, if you're not sure as well, sometimes in the question, they kind of almost give you a tip off because they write something like, write the possible, and they write solution slash, if you ever have that with a /s, okay, always double check that there's not 2. Just in case. There might only be 1, but we're kind of giving the option of there being 2, and I'll also look at the marks. Look at the mark allocation, because the more marks, the more solutions there's going to be, really. Or the more marks, the more lots of lines you're going to have to do as well. In saying that, the waste question last year wasn't a maximising question, it was a minimising question, but it was worth 6 marks just for all the working out. So it was just a question, gave you 1 mark was for like the cost matrix, and then 6 marks was for showing you working with the Hungarian algorithm, and it specifically told you had to use the Hungarian algorithm. Any questions about maximising? Yes. I would just use it anyway, yes. Unless it was like for, a 2x2 matrix and you could just try out 2 solutions. Otherwise, yes. Okay? And I think most of the time we'll tell you because that's what we're trying to test you on. Right? All right, so you had some questions you guys did last time. You can now do the maximising questions in the chapter as well. I'll come around and help you if you need it.